Assalamualaikum everybody, my name is naimasderivative, and today I'm going to be teaching everyone how to do the quotient rule in calculus and vectors. Previously, we've been doing the product rule where it is the same values but it is added in order to typically solve functions that are in this type of format. However, with the quotient rule, we're now typically dealing with functions that are in fraction format, where we have a function that has g of x over h of x, in which we can now transform that into the new formula, which is f prime of x is equal to h of x times g prime of x subtracted by g of x by h prime of x over h of x squared. Some ask why we don't use the product rule anymore for fractions, and we actually can use the product rule for fractions, but the thing is, quotient rule is easier because we don't have to use stuff to the power of negative numbers. Example as to why we don't use the product rule typically for these types of functions, though we can within the quotient rule type of lesson, is if we were to use this as an example, we would then have to change it into a product rule type of sign, bringing this up here into multiplication. So it would be 2x again, but now it's not going to be x plus 2 like this, it's going to be to the power of -1. So for our first example of how to use or apply quotient rule, the best way to actually learn how to do it is to actually put it into theory. My first step into ever solving any of these types of questions is to first apply your g and your h, as seen into this formula. So your h, as you can identify, is in the denominator. So we can just write h down here just to easily identify it. And as a result, if this is h, this has to be g. Now, my personal preference into solving these types of questions is to now get the derivative of both denominator and the numerator. G prime x, we would look at the top, we would multiply it, it would be 2x, because 2 take away 1 is 1, and we don't write to the power of 1. We could, but we don't need to. And so the same thing would apply to the denominator. H of prime x is equal to, and then we would solve it. 3 is a constant, so we would not add that, and this is just 1. So we would just write 1. To make it easier, we just bring the formula down here for the quotient rule. And all we have to do now is pretty much plug in all the values that are needed in it. So to start from the top, we can get h of x regularly, which is identifiable by here. So we would write x plus 3. Then it would be multiplied by g prime x, or the derivative of g, which is 2 of x. Now we just add the subtraction sign and get g of x by itself, the regular sign. So it would just be x squared multiplied by h prime of x, or the derivative of h, which is just 1. You don't have to add it, but just for the sake of making it easy for it to understand, we can add that. Typically for myself, I don't always add the denominator while I'm solving just the top part, the numerator, because it makes it easier. But for the sake of this video and following the proper rules, I'm going to add it. So now all you do to make it into the proper format is put the denominator, which is h of x regularly, not the derivative, but just the h by itself to the power of 2. So and then we would get the h x plus 3, which is just the regular h, not the derivative, it's just h. If it was h prime, we would put that, but it's just the regular one, squared. Now, as you can see with my very messy fraction sign, this is the proper format of how to perfectly put it into quotient rule. To our grade 9 rules, we would do distributive property. So you would multiply 2x by everything inside of the bracket. So 2x times x is 2x squared. 2x times 3 is plus, because that's the plus sign there, 6x, because there is no other sign beside, or there's no variable beside the 3. And then we would bring the subtraction sign. Always make sure to put a bracket or some form of boundary between it so you know to change the sign later, because it's not just that there, you have to also apply the sign. So x squared times 1, anything times 1 is just the same value. And then all over, again, the denominator, which is just x plus 3 squared. Next, you just continue moving. So 2x squared plus 6x, we're not going to solve yet. And then apply the subtraction sign to the bracket. So it's just going to be minus x squared over, again, your denominator, again with my very messy handwriting, but it is very hard to film. Now we have like terms. This is to the power of to the x squared. This is also to the power of squared. So 2 take away 1 is just x squared. So we would rewrite again, x squared plus 6x over x plus 3 to the power of 2. For the sake of putting it in the proper format, we would then write f of prime x, which is just showing the derivative of all of this following the quotient rule. And we would rewrite this because this is in its lowest format, meaning you cannot simplify that more unless you really want to get into the nitty and gritty of it all. But this is all that's really required of you in terms of using the quotient rule. So x plus 3 squared. And that is it. That is your final answer when applying quotient rule. So though we understand how to do the quotient rule using this formula, let's apply it with another example just to reinforce what we've previously learned in the last example. The first step, like always, apply h and g values. You can use any variables, but these are just easiest. H, g. H is always the denominator, at least for me, and it's easy to remember it that way. G is always the numerator. Second part is now to find the derivative of both the denominator and the numerator. So we'll start with g, 1 of x, and now what we do, multiply 2 by x, which is equal to 2x. 2 take away 1 is now just 1, we don't apply that, and 5 is a constant, we don't add it. Now h of x, h prime of x is equal to, like the last example of x plus 3, 1 multiplied by this is just 1, so 1 is here. 1 take away 1 is 0, so we don't put that there, which is why there is no x value or any x variable. And 2 is a constant, we don't add it. Now, like the last example, I'm going to put the quotient rule here just for the sake of it being a little bit easier and to follow and to apply. We just now plug in all of the different variables that are needed to be into the formula. So let's do it together. So it equals to h of x, normally not the derivative, but just h, which is x plus 2. Just add that there. Then we're going to multiply it now by the derivative seen by that sign of g prime of x. So if we find it, 2 of x, we located it and we add it, or multiply it, sorry. Subtraction sign, and now we do g of x, not the derivative, g, which is up here, x squared plus 5. We just put that there, and then we multiply that, sorry, that looks a little bit wonky, by the derivative of h, which is, if we find it there, 1. We don't have to add it, but it just makes it a little bit easier to follow. I went ahead and just put it all over x plus 2 squared, which is just h. And if you don't remember from last time, you have to find not the derivative or the prime of h, but you have to find h of x just by itself, which is located right here, and put it to the power of 2 in order for the fraction to be properly created. All we do, like we did last time, is to solve by simplifying it. So you apply distributive property by 2 to this whole bracket, and you multiply 2 by x, which is 2, and then x squared x by x. So you would write 2x squared, and then plus, because there's no other sign that could change that, so plus, and then 2 times 2, which is 4, and then there's nothing that the x's can change, so it's just x. Subtracted by, and then I always told you guys to add a bracket to kind of make a boundary so you don't mess up the signs later. And then x squared plus 5 times 1 with no change in the signs is just, again, x squared plus 5. I typically don't like to add the denominator type of value until the end because it makes it easier to solve. But for the sake of, again, you guys understanding better, I'm going to add it. So you do it all over. Let's make this as nice as possible. X plus 2 squared. Again, it doesn't change. It's just the same value. Now, and this is the reason why, you couldn't see it last time in the last example, but why we typically put a boundary here with these brackets, because when you apply this, obviously it's going to be negative x squared, right? But also when you're applying the negative sign or the subtraction sign to the addition sign, it now changes. But if you never added that before, it would have just been subtracted by x squared plus 5, which is wrong. So that's why we always have to add a boundary, so when you apply distributive property, all the signs that need to be changed will be changed correctly. So when we do that, we can rewrite it again. 2x squared plus 4x, that doesn't change so far, and then distributive property to both values, minus or negative x squared minus, now not plus, because negative times positive, sign rules, is -5 or -5, depending on how you want to say it, whatever's easy for you, all over again, same value, doesn't change, x plus 2 squared. So if we just write it like that, we're almost done. Step is just to simplify it as far as possible. So 2, we have to find out where all the values of the like terms are. So 2x squared minus x squared. 2 minus 1 is just x squared. Plus 4x, is there any other x's? No, so we just kind of write it there. And 5 is just a constant that we keep there. All over, again, your denominator doesn't change, x plus 2 squared. So let's just write that down. And that's it. But for the sake of making your teacher happy, let's write it in the proper format of the answer. So x squared plus 4x minus 5 all over, again, your same denominator value, x plus 2 squared. And that's it. That is your final answer used in quotient rule with a little bit more of a complicated type of question. For watching my channel today, and I hope you really enjoyed. Please leave a like, subscribe, and a follow, and turn on post notifications for next time in terms of me releasing more videos in the future.